we start recording, I also want to start sharing the lab manual. And I will answer your questions. Okay, what is titration? What's the definition for titration? What is titration? You can use your mic if it makes it easier, or you can use the chat. Titration. Okay, so titration is a methodology, is a technique, right? That you are using, is a method or methodology or a technique that you are using to find concentration of unknown sample when you have a standard. When you have a standard, so it's a method of finding concentration of a solution. So you could have acid-base titration. You could have oxidation reduction titration. You could have precipitation titration. That is known as a gravimetric base because you are weighing the product and all that. But the type of titration that is covered in this course is the acid-base titration. So quantitative chemical analysis to determine concentration of identify analyte. Okay, that analyte, it could be acid or it could be base. So you, in titration, you always have a given and you have something you're looking for. So given and looking for in a chemical reaction, it's something, it's a way of looking at the quantitative analysis that it's going to solve a lot of problems or help you solve a lot of problems. In the titration, when you have an acid and you have a base, which one is considered given and which one is considered like looking for is the one that we have known concentration. So solution with the known concentration is considered in general the given when you are thinking about the problem solving. In this technique is called the standard. So we have a standard. The one that the solution that we don't know the concentration because we already know the name of the compound, we don't know the concentration, that is your unknown or the analyte to be identified or the compound that you want to find the concentration or what you are looking for. So we already know what the acid is, what the base is. We already know the volume for both of them in titration, because when you do titration, you take a specific volume and it has to be exact. That's why we are using pipettes, because pipettes and burettes, those they have very high accuracy when you're measuring the volume. They're the most accurate equipment or glasswares in the lab that you can measure the volume. Volumetric pipette, graduated pipette, and burette. You can record the numbers with 2 decimal places, and they are very accurate. So you can find the volume. The ones that the compound with the unknown concentration would be your unknown. Couple definitions. What is endpoint of reaction? In a titration, what is endpoint of reaction? Endpoint of the reaction, it would be the point that you stop pouring the neutralizer because the reaction is over. is that the same equivalence point? And Davis, you had point where, okay, when the two balance each other out, pH becomes neutral. Bianca, point during titration when indicator shows that the amount of the reactant necessary for a complete reaction. Okay. So what is equivalence point? We have 2 points in titration. One is endpoint of reaction, and the other point is equivalence point. So endpoint of the reaction and equivalence point, often they are used interchangeably. And that's not 100% accurate. Depends on the choice of the indicator. As you noticed here, some of your responses refer to equivalence point, not the end point of the reaction. When you are performing experiment for titration, you are going to start adding. So first, let's say you have your acid in a flask, and you add an indicator to the acid. Then you are going to add enough base, or add base drop by drop until the indicator changes color. Okay? When the indicator changes color, you stop adding more base. That point is called end point of the reaction or end point of titration. So you stop adding more of the standard or the solutions that you were adding. So equivalence point is a point that number of moles of acid and number of moles of base are equal. And there was an earlier question, are they always equal? So yes, they are always equal according to balance equation, or the number of moles of acid and base, they satisfy a stoichiometric of the chemical reaction. If the acid and base, they are monoprotic, that means your acid has one hydrogen and your base has one OH, then the number of moles would be equal at the equivalence point. So did you get the definition or the difference between equivalence point and endpoint of reaction? Equivalence point, it's something that you have to kind of make assumption, or you have to choose the perfect indicator that when the indicator changes color, at that point the solution is neutral. And when the solution is neutral, you just assume that the number of moles of acid, number of moles of base are satisfying, and you had enough of each to get the solution to neutral point, or the pH 7. But endpoint of reaction, it depends on the indicator. If you search for different indicators, some indicators, they change color at the pH of 5. Some indicators, they change color pH of 7. Some indicators, they change color pH of 8, or between 8 and 9. So if your indicator, if you're using a strong acid, a strong base, the best indicator would be indicator that changes color at the neutral point, or pH of 7. So if you choose good indicator, proper with your titration or the type of acid and base you're using, the endpoint of reaction, it can overlap with equivalence point. So it's happening at the same time. But how do you know to stop titration is when you see the color change. So indicators, those are organic acid or organic base compounds. They have like a large molecule, like the structure formula, if you draw it, is not like a sodium iodide or hydrogen iodide. When you say like HNI, or when you have indicator, indicator is something that is a large molecule, is organic acid or organic base, that they have different color in acidic solution compared to basic solution. So you can use that for titration. When the solution is acidic and you are adding base, as soon as all acid is consumed, that indicator is going to, the solution gets basic and indicator will change color. So you have the color change or endpoint of the reaction. So these are some of the terms that you need to know to to have better use of the experiment. The water dissociates and it gives you 10 to negative 7 mole per liter of H plus, 10 to negative 7 of hydroxide. This is the self-ionization of the water. So when you take the negative log of concentration of hydrogen ion, or you take negative log of concentration of hydroxide ion, you can calculate the pH or the pOH. Since each water gives 1 H plus and 1 OH minus, number of hydrogens and OH ions are the same, so the solution is, the liquid is neutral. If you add acid, the concentration of OH will go down, concentration of H plus goes up, then your solution is going to be acidic. And if you add base, same thing happens. The OH would go up. And when OH concentration is higher, then the pH value is going to be higher. So pH is negative log of concentration of hydrogen ion, or pOH is negative log of concentration of hydroxide ion. When you say water has pH of 7 and pOH of 7, that means the number of concentration for acid H plus and OH minus in pure water is the same, and that is equal to 10 to negative 7. All biological molecules, they are, like if you look at the pH of the blood, is anywhere between 7.3 to 7.4, and anything higher or lower than that cannot be tolerated. So when you are doing titration, you have to pay attention to the stoichiometry of the reaction. If it's a 1-to-1 ratio, then the number of moles of acid and base equals at the equivalence point. If it's a 1-to-2 ratio, let's say you have sulfuric acid, that's H2SO4. When you neutralize with sodium hydroxide, then you need 2 sodium hydroxide per 1 mole of H2SO4. So you have to go back to the stoichiometry of the reaction in order to determine number of moles of acid with respect to number of moles of base when you are doing calculation. Another, so I hope I answered that question. Another definition here is known as a primary standard. What is considered to be a primary standard? Why are we using KHP? And what is KHP? Just please keep in mind, KHP is spelled out here, is potassium hydrogen phthalate. The abbreviation is KHP because in calculation, I see students, they are using 71. Like in the past, they have used like 71. They're adding the mass of potassium, phosphorus, and hydrogen together. That's not the potassium, hydrogen, phosphorus. This is phthalate, is a macromolecule again. The molar mass is given here, is 204. Why do we have to standardize sodium hydroxide using KHP? Because when you make the solution of sodium hydroxide, you basically measure the mass of sodium hydroxide required to make a molar solution. But sodium hydroxide is a anhydrous agent. So what it does, it absorbs moisture from the air. So by the time you open the container, you take few pellets of sodium hydroxide, you place it on the balance pan. The mass that it shows on the balance pan is not the same mass as the mass of sodium hydroxide. It's sodium hydroxide plus water, some moisture, absorbed moisture. And since we don't know how much water exactly was absorbed, we have to standardize again. So we make the solution of sodium hydroxide first, and then we are using KHP. KHP is a stable compound. So when you measure the mass of KHP, is a solid also. When you measure the mass of KHP, KHP is not changing mass. It doesn't absorb water or moisture from the environment. So the mass that you see on the balance, it corresponds to actual mass of the compound. Nothing has been added. But sodium hydroxide is not stable and is going to change. So that is that's the reason why we are using KHP to standardize sodium hydroxide to begin with. After the solution is made of sodium hydroxide, then you find the concentration, then the concentration is fixed because only solid sodium hydroxide would absorb moisture. A solution of sodium hydroxide, if it's a 1 molar or 0.5 molar, is not going to change. The concentration will stay because it's already saturated. You have lots of water in there. There's no need to get more water. And I think I answered some of the questions. Let me go back to chat room to see there's another question here. And if I forgot, you can, if I missed your question, you can type it again. And I'm looking, back titration. What is a back titration? Back titration is used when you have like a weak acid or if you have like a weak base. Let's say if you have like a antacid. You know what antacid is? You take like Tums or Alka-Seltzer or something that it helps upset stomach because your stomach is acidic, or if it's like upset stomach means too much acid. And when you take antacid, it's going to soothe. So basically, it neutralizes or lowers the acidity. So antacid must be basic. But you cannot use sodium hydroxide to take care of a stomach, upset stomach or the acidic stomach, because sodium hydroxide is a very strong base, and is going to burn, all the tissues before it gets to the stomach. So when we are talking about antacids, they are very weak base. The reaction of antacid in the titration is going to be very slow. So you add a drop, you think that is neutralized, and then after like 10-15 seconds, then the color goes away. Then you add another drop, so it's a very slow reaction. And because it's a slow reaction, it's better to add like an extra acid to it, like strong acid, HCl. Add about 10 milliliters of the HCl, concentrated, not concentrated, like higher concentration, maybe 1 molar or 2 molar HCl. You add, you give time for the reaction to happen, because if you have a weak base with the strong acid of HCl, is going to react fast. It's going to react fast, and you just give time to it to react completely. So if you have 10 milliliters of the acid mixed with the antacid, when the reaction takes place, some of the acid that you have added is going to neutralize antacid, and some acid would be left over. Now, when you neutralize or when you do titration to find how much HCl is left over, that terminology is called back titration. So you use extra acid to neutralize the base in a flask. Then you do titration to find out how much acid is left over. Then you subtract the total from what is left over. You find out how much has been consumed originally to neutralize the antacid that you started with. Did they answer the question? Or is there any other question that I missed or I did not answer? Okay, perfect. Okay. So the procedure is it's kind of something, if you see it, it's going to make more sense than me talking about it, really. But in theory, you need to know the reason why do we have to even standardize sodium hydroxide. I already told you sodium hydroxide absorbs moisture, is not stable as a solid compound, but KHB is stable. As a result, KHB is known as primary standard. But after you standardize sodium hydroxide, then you can use sodium hydroxide to titrate the HCl or titrate any other acid. With the back titration, you first you find out how much acid has been left over and how much, and if you subtract that from the total, okay, the number of moles of the acid from the total number of moles that you used, or you subtract the acid left over from the total acid used, the difference is the amount of the acid that was consumed for antacid. Good? Okay. So you find the first is like two steps in that case. It's like weighing by difference, right? If you have the mass of the beaker plus plus the liquid, okay, so you find the mass of the, you can't pour liquid on the balance pan, but if you have the liquid in the beaker, you weigh it first, you get the total mass, and then you have to subtract the mass of the beaker in order to get the mass of the liquid. So it's like you are finding by difference. Or when you measure the volume of a solid by displacement, you get the total volume, which is the volume of the solid plus the volume of the liquid in a graduate cylinder. Then you have to subtract the volume of the liquid in order to get the volume of the solid. This is the same thing here. The acid that you are using in back titration is going to be divided in two parts. Part of it would neutralize the antacid. Part of it is known as the leftover acid that you are doing the titration. But the total acid is consumed to neutralize the antacid, and also when you do titration, you find out how much is left over. So if you know the leftover and you know the total, the difference would be the what was consumed for antacid. Okay. So when you are doing titration, when you add the base, if you're adding the base to the acid and phenolphthalein, which is the indicator, phenolphthalein is colorless in acidic solution, but pink color in basic solution. When you add a drop of the base to the center, that pink color would appear, and then as you mix it, it disappears until you actually see that the pink color is going to stay for 20 seconds. At that point, you have endpoint of the reaction. Appearance of the pink color is more obvious than the disappearing, because disappearing, it would be hard to see it because it's very gradual. So that's why we prefer to always have the acid in a flask and the base or sodium hydroxide in the burette. But it doesn't have to be the case. This is just for easier recognizing of the color change. It's going to be easier to recognize. So we practiced already how are we measuring number of moles. When it comes to calculation for titration, you are dealing with number of moles. For KHP, because it's a solid compound, number of moles is moles of the number of moles is going to be the mass of KHP divided by molar mass of KHP. That's the number of moles. For liquid, when you have aqueous solution, number of moles is molarity times volume in liters. So molarity times volume in liters would give you number of moles. So when you are trying to find when you do calculation. Okay, let me look at the moles of the antacid, mass of antacid. Moles of antacid is also found from the how much of the acid was consumed to neutralize the antacid. Okay. So when you get these numbers, okay, I think that you type these numbers in the chat area with labeling the items with different trial numbers. If there is any problem, you let me know. I have to then watch that part of the video again to make sure. I think I only did 2 trials because if the numbers are close enough, I don't have to do the 3rd trial. So these numbers are coming from from the experiment until here. So you find the molarity of the sodium hydroxide. Okay, so you find the number of moles of the KHP. When you have the mass of KHP, moles of KHP would be mass divided by 204. And then that is equal to number of moles of the sodium hydroxide. And you divide by volume of the sodium hydroxide and you get the molarity. So when you have the molarity for sodium hydroxide, you use the molarity for the next calculation, for calculation of the other one. So if you have the molarity and you have the volume of sodium hydroxide, then you can find the number of moles of sodium hydroxide. Okay. Do you have any questions? Questions? No? Okay. It's February 23rd. Next week is a spring break. Well, when you work from home, I don't know what spring break is going to be, and you're not, it's not safe to travel. But I would spend the time to grade some papers for you. So that would be my spring break. The next week we have no class. It's the spring break. I will see you in 2 weeks. But first, let me call for attendance. Hannah? Hannah? This is for attendance. Hannah is absent. Okay. Sahar? Thank you. Sonia? Ashley? Leah? Caitlin? Jennifer? Gret? Carmen? Danielle? Davis? Caden? Shruti? Kate? Bianca? Monisha? Jada? Jose? Sierra? Javier? Lillian? Lillian? Sorry, I didn't. Okay, that's okay. I had absent for you, so I'm sorry. Javier here and Lillian. Did I get Lillian? Lillian, are you here? Aisha? Matthew? And Ria? Okay. Thank you so much. If you have any questions, you may stay to ask your questions. If you don't have questions, you can start watching the video at this point. And I hope you have a nice rest of the week and a nice spring break. I will see you in 2 weeks. Thank you. The day of the next lab, which is March 9th. Your assignments would be due in 2 weeks from today, before 8 a.m. March 9th. Perfect.